A very pleasant and good morning to one and all my dear students. How are you all? I hope you all are fine. Right. In previous classes, we have seen the start of the unit 4, isn't it? Yes, work, energy, power. That is the fourth unit. What is work and what is energy, what is power, all those things we have seen. Okay. Half of the lesson we have completed. Rest half we will see in today's class. Okay, children? Right. Okay, you are doing regularly the homework and assignment, classwork, everything. I'm really happy of you, my dear children. Some of them are not doing regularly. You should do it regularly, okay? Because it is for your benefit and it is for your sake only, okay? If you do the homeworks and assignment properly, which we are giving, that will be useful for you to score good marks, okay? And it may also be noted as a mark for your exams, everything, okay? Right? So every time you do the work which we are giving, okay, children? Let's start, okay? Yes, in the previous classes, we have seen about the power. What is power? Power is a measure of, okay, work done by time taken. In a certain time period, how much work is done, okay? That is the power. So, all those things we have seen in the previous classes, okay? Right. From today, we are going to see relation between power and velocity. Okay. First of all, we are going to see what is the relation between power and velocity. Okay. Okay. The work done. Okay. The work done by a force for a displacement. Okay. Work done by a force for a displacement is equal to force into displacement. Work done na enna? Work done equal to force into displacement. Okay. Force into displacement. சரியா? So first left hand side எடுத்துக்கலாம். சரியா? W equal to F dr. W equal to force into displacement. Displacement வந்து dr னு எடுத்திருக்காங்க. அப்போ W equal to F into dr. Okay. So that is work done. Work done is equal to, first we are going to integrate. Okay. First we are going to integrate the left hand side and then we are going to integrate the right hand side. Okay. First of all, W equal to dw integrate பண்ணோம் அப்படினா w வை integrate போட்டா எப்படி சிம்பிள்ல போடலாம் dw dw வை integrate பண்ணாதான் நமக்கு w கிடைக்கும், isn't it? So first of all left hand side நம்ம வச்சுக்கிறோம், ஓகேவா? Right. So multiply by dt. அப்போ dw by dt into dt. ரெண்டு dt மே cancel ஆயிரும். சரியா? So அதனால ரெண்டுமே வச்சு தான் நம்ம இது சால்வ் பண்ண போறோம். So velocity equal to என்னது? Displacement by time. அப்போ அது எப்படி எடுத்துருக்காங்க? dr by dt. dr தான் displacement, dt தான் time. So dr by dt. So dr equal to v into dt. Okay? So fdr is written as f into dr by dt into dt. Okay? So solve பண்ணி பார்த்தோம்னா நமக்கு கடைசில கிடைக்கக்கூடியது என்னது? dw by dt equal to f into v. So work done க்கும், ஓகேவா, the power க்கும் velocity க்கும் உள்ள relation கொடுத்திருக்காங்க. Next, what is collision? Okay, what is collision? So collision is a common phenomenon, okay, that it happens around every now and then. இப்போ நடக்கலாம், next நடக்கலாம், நடந்துகிட்டே இருக்கலாம், ஓகேவா? So it happens now and then. Okay. So for example, carom board, billiards, marbles, etc. So collision can happen between two bodies with or without physical contacts. Okay. So linear momentum is conserved in all collision process. Okay. Linear momentum. So எல்லா collision processலயும் ஒரு momentum நடக்குது. So என்ன அப்படின்னா when two bodies collide, okay, ரெண்டு balls வச்சிருக்காங்க, ரெண்டு balls-ஐயும் collide பண்றாங்க, ஓகேவா? When two bodies collide, the mutual impulsive forces acting between them during the collision time produces a change in their respective moment. So that is the first body exerts a force F12 on the second body. So from Newton's third law, the second body exerts a force F21 on the first body. So this causes a change in the momentum of the first body and second body. Okay, you understood? Right. Now there are two types of collision, that is elastic collision, inelastic collision. Okay, two types of collision, elastic and inelastic collision. So what is elastic collision? The bodies collide and move away from each other. But inelastic collision, bodies move together after the collision. Bodies move together after the collision. Okay, do you understand? Now, what are the types of collision? Inelastic collision. Okay, in an elastic collision, momentum and kinetic energy are conserved. Okay, in an inelastic collision, kinetic energy is not conserved. So, although momentum is still conserved. Okay, va? Next, the difference between inelastic and elastic collision. Okay, the difference between elastic and inelastic collision. So, elastic collision la total momentum conserve ஆகுது. Inelastic collision la total momentum conserve ஆகுது. Elastic collision la total kinetic energy conserve ஆகும். But inelastic collision la total kinetic energy is not conserved. Total kinetic energy is not conserved. Okay. Next, in elastic collision, the forces involved are conservative forces. The forces involved are conservative forces. But in inelastic collision, the forces involved are non-conservative forces. Non-conservative forces. Okay. What is elastic collision? Mechanical energy is not dissipated in elastic collision. Okay. But in inelastic collision, mechanical energy is dissipated into heat, light, sound, etc. Okay. Right. Do you understand? In inelastic collision, momentum is conserved. Angayum momentum conserved. Kinetic energy not conserved. There kinetic energy conserved. See the picture. Rendu object me collision abdina rendu modikranga. Okay va? So before collision eppadi irukudhu. After collision eppadi irukudhu. That's all. Okay. Elastic collision in one dimension. Okay, elastic collision in one dimension. So let's see. Okay, consider two elastic bodies. Consider two elastic bodies of mass m1 and m2 that is moving in a straight line on a frictionless horizontal surface. Okay, so I told you that what is elastic collision and what is inelastic collision. Okay, so in any collision process, okay, in any collision process, the total linear momentum and the total energy are always conserved. So whereas the total kinetic energy need not be conserved always. So some part of the initial kinetic energy is transformed to other forms of energy. Okay. So this is because the impact of collisions and deformation occurring due to collisions may in general produce heat, sound, light, etc. Okay. So by taking these effects into account, we classify the type of collisions as elastic collision, inelastic collision. Okay. What is elastic collision? So in a collision, the total initial kinetic energy of the bodies is equal to the total final kinetic energy of the bodies. That is after collision. So that is the elastic collision. Okay. Total kinetic energy before collision is equal to total kinetic energy after collision. அதுதான் என்னது elastic collision. Inelastic collision என்னன்னு பார்த்தோம். ஒரு collisionல the total initial kinetic energies before collision is not equal to the total final kinetic energy. So என்ன அப்படினா inelastic collisionல total kinetic energy before collision is not equal to total kinetic energy after collision. Do you understand? So even though kinetic energy is not conserved in inelastic collision, so this is because the total energy that contained in the kinetic energy term is also termed as del Q. அது எப்படி சொல்றாங்க? del Q அப்படினு சொல்றாங்க. Total kinetic energy represent பண்றது del Q. So which includes all the losses that take place during the collision. So now note the loss in kinetic energy during collision that is transformed to another form of energy like sound, thermal, etc. So further, if the two colliding bodies stick together after collision, such collisions are known as completely inelastic collision or perfectly inelastic collision. Okay. So such a collision is found often. So for example, when a clay putty is thrown on a moving vehicle. The clay putty na bubble gum. Okay va, ஒரு bubble gum எடுத்துக்குவீங்க. அந்த bubble gum ஒரு moving vehicle நீங்க வீசும்போது என்ன ஆகும்? That sticks to the moving vehicle and they move together with the same velocity, isn't it? அப்போ அந்த கார் போற velocity தான் அந்த bubble gum ஓட velocity இருக்கும். That is the inelastic collision. That is the inelastic collision. Okay, so now we are going to see the elastic collision in one dimension. So elastic collision in one dimension. Okay, consider two elastic bodies. Okay, two elastic bodies of masses m1 and m2 that is moving in a straight line. So now on the mass m1 oda initial velocity u1 and the mass m2 oda initial velocity u2. final velocity வந்து v1 v2 னு எடுத்துக்கலாம் ஓகேவா so in order to have collision we assume that the mass m1 moves faster than mass m2 okay that is u1 is greater than u2 for elastic collision the total linear momentum and kinetic energies of the two bodies before and after collision must remain the same okay remain the same okay so before collision momentum equal to p equal to mv that is momentum is represented by p and mass into velocity so before collision is equal to after collision so from the law of conservation of linear momentum okay the total momentum before collision is equal to total momentum after collision okay they understood right okay now we are going to divide the equation and there is a derivation in your book okay there is a derivation in your book take page number 195 okay total kinetic energy so before kinetic energy after kinetic energy so collision equal to half mv square the formula அப்ப initial apply பண்ணும்போது u போடுறோம் final apply பண்ணும்போது v போட்டு நம்ம formulaல so initial equal to final that is half m1 u1 square plus half m2 u2 square equal to half into m1 v1 square plus half into m2 v2 square so that is equate பண்ணும்போது அந்த 2 cancel ஆயிருது so m1 into u1 the whole square minus v1 equal to m2 into v2 the whole square minus u2 square இப்போ using the formula a square minus b square that is a plus b a minus b அந்த formulaவை substitute பண்றோம் ஓகேவா பேஜ் நம்பர் 195 ல இருக்கு கவனிச்சுக்கோங்க so m1 into அந்த a square minus b square formula இத அப்ளை பண்ணும்போது u1 plus v1 into u1 minus v1 equal to m2 into v2 plus u2 into v2 minus v2 so இத சால்வ் பண்ணி ரீஅரேஞ்ச் பண்ணி நம்ம கொண்டு வந்தோம்னா நமக்கு கடைசியா கிடைக்கிறது என்னது v2 equal to 2m1 by m1 plus m2 into u1 into m2 minus m1 by m1 plus m2 இதே மாதிரி நமக்கு கிடைக்குது அப்போ கேஸ் 1ல எடுத்துட்டோம்னா m1 equal to m2 அப்போ இதுல அப்ளை பண்ணுங்க m1 equal to m2 அப்ளை பண்றாங்க நெக்ஸ்ட் கேஸ் எடுத்துக்கிட்டோம் அப்படினா when bodies have the same mass as m1 into m2 second body is at rest u2 equal to 0 போட்டு பண்ணனும் next ஒரு equation கிடைக்குது third case என்ன அப்படினா first body is very much lighter than the second body so என்ன ஆகும் m1 by m2 equal to 0 u2 equal to 0 okay you understood next case 4 எடுத்துக்கிறோம் case 4 எடுத்துக்கிட்டோம்னா the second body is very much lighter than the first body so அங்க u2 equal to 0 m2 by m1 equal to 0 அது டார்கெட் பண்றாங்க பண்ணா நமக்கு ஒரு ஈக்குவேஷன் கிடைக்குது okay do you understood right okay next perfectly inelastic collision okay see here before collision after collision so before collision ல எப்படி இருக்காங்க after collision ல எப்படி இருக்காங்க so அதோட mass வந்து collision ஆனதுக்கு அப்புறம் m1 plus m2 ஓகேவா so before collision after collision okay do you understood now there are two cases okay case 1 case 2 case 3 case 4 four cases are there okay in elastic collision okay right so when the bodies has the same mass m1 equal to m2 na enna okay when the bodies have same mass okay and the second body is at rest u2 equal to 0 okay and the third case the first body is very much lighter than the second body first body is very much lighter than the second body okay case 4 la second body is very much lighter than the first body second body is very much lighter than the first body okay they understood so these are the cases okay right so loss in kinetic energy for perfectly inelastic collision loss of kinetic energy for perfectly inelastic collision so in perfectly inelastic collision the loss in kinetic energy okay during collision is transformed from one form of energy into another form okay form of energy like sound thermal heat energy light energy okay so let the kinetic energy be the total kinetic energy before collision and the kinetic energy be the total kinetic energy after collision okay you understood see here see this is the derivation okay so ke that is the kinetic energy it may be written as kinetic energy is equal to half mv square normally நமக்கு தெரியும் kinetic energy is equal to half mv square அப்போ initial velocity u ன்னு எடுத்துக்கறாங்க சரியா so loss in kinetic energy is equal to kinetic energy before collision minus kinetic energy after collision. Okay va? So loss in kinetic energy is equal to half வெளிய எடுத்துக்கோங்க m1 u1 square plus half into m2 u2 square minus half into m1 plus m2 into v. v ங்கிறது என்னது after collision. So before collision வந்து initial u velocity எடுத்துக்கறாங்க, after collision வந்து v எடுத்துக்கறாங்க. Okay வா? Do you understood? So by the law of conservation of linear momentum, m1 u1 plus m2 u2 equal to m1 plus m2 into v. So finally நமக்கு கிடைக்கக்கூடிய formula என்ன அப்படினா loss of kinetic energy, that is denoted by del q. சரியா? del q equal to kinetic energy before and after collision. So that is equal to half into m1 into m2 divided by m1 plus m2 into u1 minus u2 the whole square. You understood? Now coefficient of restitution. Okay, suppose coefficient of restitution என்ன அப்படினா it is defined as the ratio of velocity of separation after collision to the velocity of approach before collision. So after collision ko before collision ko உள்ள difference. So E equal to என்ன எடுத்துக்கலாம் அப்படினா velocity of separation by velocity of approach. அப்போ அதை எப்படி சொல்லலாம் அப்படினா velocity of after collision velocity divided by before collision velocity. So after collision velocity வந்து v1 v2 தான், before collision வந்து u1 u2. அப்போ v2 minus v1 by u1 minus u2. So in an elastic collision we have obtained the velocity of separation is equal to velocity of approach. அப்படிதானே elastic collisionல பார்த்தோம். So இதுக்கு என்ன example அப்படினா rubber ball ஒரு plastic ball எடுத்துக்கறாங்க. Suppose we drop a rubber ball and a plastic ball on the same floor. Okay, so the rubber ball will bounce back higher than the plastic ball, isn't it? Have you noticed? So this is because the loss of kinetic energy for an elastic ball is much lesser than the loss of kinetic energy for a plastic ball. Okay, the amount of kinetic energy after the collision of two bodies in general, okay, can be measured through a dimensionless number that is called the coefficient of restitution. Coefficient of restitution. Okay, so now this implies that the coefficient of restitution, okay, u1 minus u2 equal to v2 minus v1. அப்போ அது v2 minus v1 by u1 minus u2 ன்னு போட்டோம்னா ஆன்சர் நமக்கு 1 கிடைக்குது, that is equal to e. So e தான் என்னது coefficient of restitution. So if this implies that coefficient of restitution for an elastic collision E equal to 1, physically it means that there is no loss of kinetic energy after the collision. So the body bounces back with the same kinetic energy, which is usually called as perfect elastic. So in any real collision problems, there will be some losses in kinetic energy due to collision, which means E is not always equal to unity. So if the ball is perfectly plastic, it will never bounce back, and therefore the separation of velocity is 0 after the collision. So the value of coefficient of restitution E equal to 0. So in general, the coefficient of restitution for a material that lies between 0 and 1. Lies between 0 and 1. Okay. Okay children, that's all. This lesson is completed. Okay. Lesson 4 is completed. In next class, we will see the unit 5. Okay, now it's time for your homework. Okay, write any 10 one words from the topics which I have taught. Okay, by the way, you have to mark the book back one words, short answer questions and long answer questions, numerical problems, everything. You go through it. I think you may be having guided everything. So day by day you study it and don't waste a single time. Okay children, your homework is write 10 one words. That is your homework. Okay, and your assignment is book back short answer questions and long answer questions. Okay, short answer questions motto 5 irukku, long answer question is also 5. Just 10 questions are there. Okay, you have to study well. Okay, and make it as a assignment. Make it as a assignment. Okay, study well and make it as a assignment. Okay children, study well, don't waste a single time. Have a nice day. Thank you.